Okay, so what are neural networks? Okay, so, neural networks is a way, okay, to develop a model, to develop a machine learning model or an artificial intelligence model. Okay, and the way it does is it sort of mimics kung paano nag-work yung brain. Okay, and why do we want to use neural networks? The reason why we want to use neural networks is because if we have a large data such as this, okay, using yung techniques na ginamit natin before, okay, will give us or will lead to a very slow computation of the weights, very slow updates ng mga weights. Okay. And you don't want that. Okay, pagdating sa artificial intelligence, you want a response that is less than a second, di ba? Kung pag nag-type in ka ng information, nagbigay ka ng data, gusto mo na in less than a second, alam mo na kagad yung tawag dito, prediction. May model ka na kagad para mag-predict ng certain stuff. Because ultimately, ano bang purpose ng artificial intelligence? You want to tawag dito, develop some system that mimics how we humans think. Right? And tayo, pag pinakitaan mo tayo ng ng graph, okay, we can immediately deduce some information from that graph. Okay? If you show us a figure of a flower, itong flower na ito, alam kaagad natin kung anong tawag dito? Alam kaagad natin, first of all, na flower yan, right? Kung anong kulay ng flower, kung anong characteristics ng flower, and sometimes, okay, kung anong pangalan ng flower. For a computer, you have to teach it. Okay, and how do you teach the computer? So you have to provide millions of or a number of data. If you give it one picture, sabihin mo na, okay, itong picture na ito is a flower. If you give it another picture, okay, to test if it has learned that, hindi tawag dito, there's a 1 out of 2 chance, okay, na magiging tama or mali yung computer. Right? Kasi isang picture lang yung binigay mo sa kanya. But for us humans, pag pinakita mo tayo ng picture ng flower, tapos sunod na ipakita sa atin ay picture ng bola, alam kaagad natin na yung bola ay hindi flower. Okay? So we don't need to have a large amount of data just para lang matutunan natin yung isang bagay. Okay? For a computer, you need to provide it a large amount of data. Okay? So that's how things work now for artificial intelligence. Okay? And to speed up the computation, we need neural networks. Gaano kalaking data ba ang pinag-uusapan natin dito? Well, this is just one data point, itong flower na ito. And this image has a pixel size of 1,680 by 2,240 pixels times 3. Bakit 3? Kasi it has 3 layers. The red, green, at saka blue. So, gaano karaming pixels meron dito? Okay, gaano karaming information ang meron dito? It has 1,680 times 2,240 times 3. Okay? By pixels of information. Okay? That's, ilan na yan? Million, di ba? That's a megapixel, okay, of information. Now, each information dito, each bit, okay, corresponds to a certain number. Okay, at yung number na yon, okay, corresponds to kung ano yung color. Like for example, itong green na nandito, ito yung 34 na nandito dyan. Okay, and if you go towards here, these are lighter colors, so higher yung values. Okay, so ito yung tawag dito, histogram, okay, nung values corresponding to yung intensity ng color. Okay, nung image na ito. Okay, so that's how much information present dito sa flower. Just single image. Pero remember that to teach a computer, we need to provide it several images. At times, gusto mo thousands of images, 10,000, 2,000, 20,000 images para lang matutunan niya na yan ay isang flower. Okay. So this flower has 3.7 pixels per layer. And there are 3 layers. Itong image na ito na hindi flower, so picture to ng mangga, this has 1.2 pixels per layer. Okay, and each pixel is described by this number. Okay, so how do we tell the computer na yun ay flower or hindi? Well, ang gagawin natin, kung meron itong ganito karaming pixels per layer, so ang pixels na yun is 1680 by 2240. Ang gagawin natin dyan is if-flatten natin yan. What do we mean by flatten? So instead of a 1680 by 2240 na matrix, gagawin natin siyang 1 by 3.7, sorry, 1 by 3.7 matrix. So is single row lang yan for one flower. Okay, single row for one flower. Tapos, magdadagdag tayo ng isang column. Okay, dun sa dulo. At yung last column na yon, okay, is called the label column. And we assign it a 1 kung flower ito. So ito na yung na-flatten na ano, no? So originally, this is 1680 by 2240. This is now the 1 by 3.7 million. Okay, so this is a 1 row by 3.7 million column. And then dun sa very last column, nilabelan natin siya ng 1 kung flower siya. Ito is another image. Kung ano to, kung hindi to flower, label natin sa kanya 0. Ito hindi to flower, so 0 din ito. Ito flower to, so lalagyan natin siya ng 1. So that's how we create the matrix, okay, that we feed to the computer. Okay? So that's just one picture, o yung one row na yan. So if we have 20,000 pictures, gaano kalaki tong matrix na to? This is 20,000 by 3.7 million na matrix plus one column, di ba? So 3.7 something, and then you add this one column. Ang laking matrix nun, di ba? So fortunately, of course, pag may knowledge kayo sa linear algebra, it makes things a bit easier for us. Okay, kasi and yung computers ngayon ay designed naman to handle matrices, to handle linear algebra, okay, which is good. Now, this is a very large matrix, which means na ang tawag dito, this begs the question, how many theta values do we need to compute? Okay, how many features does this system have? Okay. And if you recall, dun sa multivariate linear regression, meron tayong 6 columns describing 5 features and one di ba, one label. Okay. So, merong doon, ilang features? 1, 2, 3, 4, 5, 6 actually, 6 na features. And then meron ka pang bias. So 6 features plus bias. Pero dito, ilang columns meron dito? There's 3.7 million columns, which means that you have 3.7 million features. And each of those features ay i-update ng computer every epoch. Na-imagine nyo yung work na required para sa computer just to learn all these things. Okay, so that's what we want the computer to do if we want it to learn how to classify images. And we're just talking about a binary classification. It's a flower or it's not a flower. Paano kung kung multi classification? Okay. Then it's even complicated, right? Dadagdag tayo ng several columns dito, depende kung ilang systems i-classify natin. Okay? So pinapakita ko lang sa inyo yung extent nung work na kailangan. Now, for us humans, of course, meron tayo nitong brain, and in our brain, we have this biological neuron. And yung neuron is a single brain cell. Okay, and itong single brain cell na to has this cell body. Okay, at itong cell body na to, siya yung nagpo-process ng information, nung stimuli. So we have all these stimuli coming in, okay, through the dendrites. Ito yung mga dendrites, ito yung input dun sa neuron. And then yung output, okay, nung cell body ay dito nilalabas sa axon. Okay? And then it connects to other neurons. So you have one neuron connected to another neuron, and so on and so forth. Okay, so that's how biologically the brain works. And yung processing happens here in the cell body. So you have input, cell body, and then output. Okay? And we model a neuron sa neural network the same way. We have this node, okay, wherein dun sa node ay meron tayo nitong expression, which is ang tawag dito, which is our activation. Oh, sorry. No, hindi activation. Activation is f of z. So this is just this computes for the z, and then we have this f of z, which is the activation. Okay, for linear regression, this is theta transpose x. And for anong tawag dito? For logistic regression, okay, this is z. Z is equal to tama. Z is also theta transpose x, right? And then sa linear regression, this is theta transpose x plus b, or theta transpose x lang din. Pero sa logistic regression, this is 1 over 1 plus exponential minus z. Okay. So yun yung ginagawa ng activation dito. Yan ang nangyayari sa node. And then we get these inputs from these lines here. Okay, and then itong W, ito yung mga theta. Okay. So theta, this is theta 1, this is theta 2, this is theta 3. We also call them weights. Pagdating sa modeling ng neural networks, we call the theta values as the weights, but they're also called features. Okay. Okay, so essentially, ang ginagawa natin dito is pinapalitan natin itong weights na to. The same way sa linear regression, di ba? Pinapalitan niyo yung theta na at saka theta 1 para mapalitan yung linya. Okay, para mapalitan yung slope ng line, right? Okay, dito papalitan niyo rin yung weights, W1, W2, W3 each iteration, in each iteration. Now, for each iteration, bibigay din kayo ng output. Okay. So yan sa isang node lang yan. This is just one node in a neural network. Let's talk about yung activation function first. Okay, itong activation function, marami yan. Okay, it's not just simple activation function. It's not just linear. Linear, alam na natin. Okay, napag-usapan na natin yung linear, yun yung una natin ginawa sa linear regression. We just discussed sigmoid and logistic. Ito yung shape niya. Okay, from 0 to 1, and then if z is equal to 0, then you have g is equal to 0.5. Ang similar sa kanya is hyperbolic tangent. Okay, but sa hyperbolic tangent, it gives out a value that is positive if z is equal to 0. And if z is greater than 0, sorry. If z is less than 0, then it gives out a value that's negative. So this has negative to positive values kumpara sa sigmoid, which gives out 0 to 1. Okay, then you also have these binary step function. Okay, of course, problematic itong binary step function when you take the derivative, di ba? Kasi ano siya, singularity, right? Then you have this ReLU function. This is actually very, very famous. Medyo common itong ReLU function na ito. Then you have this leaky ReLU na ganito yung itsura. Parametrics, CELU, ELU. Okay, we have all of these. Okay. Ang pinaka-common dyan is itong ReLU, sigmoid, at saka hyperbolic tangent. Okay, so you already know itong sigmoid logistic. So advantage yan is useful for models where the prediction is a probability in the range between 0 and 1, differentiable, at saka continuous siya na. It has a differentiable and continuous na gradient. Ang problem lang dito is suffers from a vanishing gradient problem. And you only worry about the vanishing gradient problem pagdating sa time series prediction. Okay. Okay. Then you have this hyperbolic tangent. Ang behavior niya is the same as sigmoid logistic, but its output is not zero-centered. So it gives out positive output at saka a negative output. It also suffers from vanishing gradient problem. And the the equation for the activation is exponential x minus exponential negative x over exponential x plus exponential minus x, which is your expression basically for the hyperbolic tangent. For the rectified linear unit or ReLU, okay, ang isang advantage ito is computationally efficient. And of course, another advantage is accelerates the convergence of a gradient towards the global minimum of the loss function, which is what you want. Gusto mo nasa global minimum, hindi dun sa local na minimum. Ang disadvantage is that it creates dead neurons which never get activated during back propagation. Okay? So in other words, once na ma-process niya lahat nung network na yon, pwede siyang mag-set ng neuron na 0 and it doesn't get updated, okay, in the next iteration, in the next epoch. Okay. Then you have this softmax, which is also popular. Okay, and you usually use it if you want to do multi-class classification. Okay, now how do you choose the right activation function? So as a rule of thumb, you can begin with using the ReLU activation function. Okay, and then move over to other activation functions if ReLU doesn't provide optimum results. Okay, so ReLU muna. Okay, and you only used ReLU dun sa hidden layers. Okay, explain ko mamaya kung ano yung hidden layers. Sigmoid, logistic, and hyperbolic tangent functions should not be used in hidden layers, okay, as they make the model more susceptible to problems during training, like vanishing gradients. Swiss function is used in neural networks having a depth greater than 40 layers. But at least from my experience, hindi ko pa naman ginamit yung Swiss na function. Typically, mostly ang ginagamit ko, oftentimes ang ginagamit is ReLU. Okay, now finally, a few rules for choosing activation function for your output layer based on the type of prediction problem that you're solving. So regression, pag linear activation, of course, pag regression problem, yung sinasolve ninyo. Pag binary classification, you use logistic activation function. This is obvious kasi it's just 0 and 1. Pag multi-class classification, you use softmax. Pag multi-label classification, you use a sigmoid function. Okay, then yung activation function in the hidden layers is typically chosen based on the type of neural network architecture. Typically, pag convolutional neural network, you use a ReLU activation function. Then pag recurrent neural networks, you use a tangent, hyperbolic tangent, or sigmoid activation function. Okay, so just a few rules of thumb. A rule of thumb, kung kailan nyo gagamitin itong mga activation function na to. So this table, if you know this table or know this slide, then you'll survive pagdating sa modeling. Okay. So, how does this neural network work? Okay, so tulad ng sinabi natin kanina, we have these inputs, x1, x2, x3. We have this node, and we have this output A. Now, bawat isa sa mga input na ito, mag-assign ka ng weight dyan. Okay, and yung weight is used to compute Z. And then once you solve for Z, you use that for the activation function. Then the activation gives you activation function gives you the output. Okay. Now, of course, we need to add the bias, okay, to the node. Okay, so instead of just using x1, x2, x3, we need to add x naught dito. Okay, so magkakaroon din ng corresponding na weight, W naught, itong x naught na ito. Now, we don't have to worry about x naught too much because anong alam natin about x naught? We just set it to 1. Di ba? Itong x naught, parati lang natin sineset yan sa 1. At ang poproblemahin lang natin is yung W naught, W1, W2, W3. Okay. Pasok dito to compute for the activation, and the activation gives you an output. Okay, ang output is this. Okay? Now, this is a basic neural network. So a basic neural network has at least 3 layers. Itong layer 1 is the input layer. Layer 3 is the output layer. At itong layer 2 ay yung mga hidden layers. You can have a single hidden layer. This is called a shallow neural network. If you have 2 hidden layers, you can still call it a shallow neural network. But if you have more than 2, you have 3 up to 10, and then 40 or 100, then you call that a deep neural network. Okay? Okay, so paano nag-work tong hidden layers na ito? Well, dito sa hidden layers na ito, dito nyo kinocompute yung activation, okay, nung bawat nodes. Okay? And you call the weights, dito ang weights hindi na natin nilabel as W, you call them as theta. Okay? Where remember, yung J is classified as the row, di ba? So matrix of weights controlling the function mapping from layer J to layer J plus 1. So this is layer 2. So this maps. Okay, so pag sinabing super 2, this is layer 2. Okay? And pag sinabing subscript na 3, 2, 1, this is node 1, node 2, tsaka node 3. Okay, so that's how we label the hidden layers. Okay, so how do we get the activation of this? Remember, mag-add tayo ng theta ng x1, x naught dito. Okay, and then meron ka pang weight corresponding weight that connects x naught at saka a1. Okay, and then from there you compute the activation, and then you pass the activation to this node here, which is layer 3. And then itong layer 3 na to, siya magbibigay nung output. Okay, so this also has its own activation. Okay? Okay, so how is this going to work? Okay. Okay. So ganito yung mangyayari sa kanya. Oops, sorry. So ang mangyayari dito is this. We want to solve for A1 super 2, A2 super 2, tsaka A3 super 2. Okay. How do we solve for A1 super 2? Well, we need the inputs x1, x2, tsaka x3. Tapos yung corresponding na weight that connects x1 to A1 super 2. The weight, okay, that describes the connection between x2 at saka A12. Then the weight that describes the connection between x3 at saka, AX3 and A1 super 2. Okay. So itong 1, 2, 3. Kailangan i-compute natin yung mga weights na yan. But remember, meron ka pang bias. So x naught, and then yung weight that connects x naught with A12. Okay, so you have 4 terms, okay, that connects yung layer 1 to layer 2. Okay? Now, okay, etong theta has a superscript na J. Okay, so this maps layer J to layer J plus 1. So that means na kung may superscript ka na 1 sa theta, okay, it means na it's from layer 1 to layer 2. If you have a superscript na 1, okay, layer 1 to layer 2. Dito, ang superscript ng theta dito is 2. So it connects layer 2. It is this weights. Itong theta super 2 na to, yung mga weights na nandito. Ito yung mga linya na yan. Okay? Okay, now, meron ka ring subscript dito sa theta. 1, 0. Ano yung 1, 0 na yan? This is layer 1, and this is for layer 1, and this is for layer 2. So, ito yung x1 sa layer 1, and then sorry. Ito yung, baliktad, sorry. Yung, etong second na number dito is from layer 1. So, this is the bias connecting layer 1, A1. So, this is x1 connected to A1. This is x2 connected to A1. And this is x3 connected to A1. Okay, makikita naman natin dito yan. X0, dapat 0 yan. X1, dapat 1 yan. X2, dapat 2 ito. At X3, dapat 3 yan. And then A1, so 1, 1, 1, 1 yung unang subscript. So all of these 4 na weights describes this 1, 2, 3, 4 na weights respectively dito sa figure. And that gives us A1 super 2. Well, we get A1 super 2 after we use the activation function. Now we get A2 super 2 from the bias. So may X na tayo dito. So ito yung theta na ito is, itong theta na ito is theta sub 2, 0. Okay, from the bias. Etong theta na ito, x1 to a2 is theta 2, 1. Etong theta na ito is theta 2, 2. At itong theta na ito is theta 2, 3. Okay, so that's how you compute for a2. And you compute the same way for a3 dito. Okay, so now, how many weights are we solving for? 1, 2, 3, 4. 1, 2, 3, 4. We have 12 weights just to connect a layer which has 3 inputs to a second layer which also has 3 nodes. Okay, so how do we know the number of weights? Since we're adding a bias here, ang gagawin natin to compute for the number of weights is we multiply 3 by 4. Diba kasi magdadagdag tayong bias. So 3 by 4 is 12. So we are solving essentially for 12 weights. Okay, connecting layer 1 to layer 2. Okay, layer 1 to layer 2 pa lang yan. What about layer 2 to layer 3? So layer 2 to layer 3, we have, since we're adding 1 here, so we multiply 1 by 4. Kasi may magdadagdag tayo ng bias, remember. So 1 by 4. So we actually have 4 weights that connects layer 2 to layer 3. At ito yung 4 weights na yon. Theta 1, 0, yun yung nandito. Theta 1, 1, it is this one. Theta 1, 2, it is this one. Theta 1, 3, it is this one. Okay, then may superscript na 2 doon. Okay, so we essentially solving for 16, diba? 12 connecting layer 1 to layer 2 and another 4 connecting layer 2 to layer 3. Okay? So ganyan mag-compute nung weights. So initially, you set the weights to some random value. And then for each iteration, pinapalitan nyo yung weights na ito. Okay? Hanggang sa yung h theta compared with yi, yung error na yun, yung cost function na yun becomes small. So remember, sa linear regression, ganun din yung ginagawa natin. Sa linear regression, dalawa lang yung kinocompute natin, di ba? Theta naught at saka theta 1. Okay, ngayon, we're solving for 16 theta values.